They tell you space is empty, a vast silent canvas of nothingness, stretching beyond comprehension, a pristine vacuum, utterly devoid of matter, energy, or even a whisper of activity, a cosmic void, a blank slate, a tranquil, absolute zero. That's the lie. That's the grand deception. Because out there, in the deepest, darkest reaches of what we call nothing, the universe isn't silent. It's screaming, it's boiling, it's a maelstrom of furious, unseen energy, constantly creating, constantly annihilating, a chaotic ballet of existence erupting from the very fabric of reality itself. But if nothing isn't nothing, then what is this cosmic void? The lie, you see, is born from our very perception. When you gaze into the yawning abyss between galaxies, or even just consider the vast emptiness between atoms, what do you see? Nothing. Just space. Cold, black, silent. Our intuition screams that if you strip away all matter, all light, all fields, if you create the perfect absolute vacuum, you are left with truly, perfectly nothing. It's a concept so fundamental, so seemingly self-evident, that it underpins our entire understanding of the cosmos. Where there's nothing, there's no energy, no activity, no potential. It's the ultimate cosmic blank, and for centuries, that was the accepted wisdom. A vacuum was a vacuum, a pristine void, the ultimate cosmic desolation. But then the quantum revolution erupted. It tore down our neat, tidy understanding of reality and replaced it with something wilder, more terrifying, and infinitely more profound. The moment we peered into the subatomic realm, into the very fabric of existence, we uncovered a truth that shattered the notion of an empty void. We learned that the universe abhors perfect stillness. It utterly refuses to be quiet. Imagine trying to measure the position and momentum of a single, solitary particle. Heisenberg's uncertainty principle screams at you. You can know one, but never both. With absolute precision, the more precisely you pin down its location, the fuzzier its momentum becomes, and vice versa. It's not a flaw in our instruments. It's a fundamental property of reality. Now apply that same relentless logic to nothing. If space were truly empty, truly devoid of all energy, then every single field, the electromagnetic field, the gravitational field, every quantum field that underpins existence, would have to be perfectly, absolutely zero. No fluctuations, no motion, total stillness. But that, my friends, is forbidden, utterly, irrevocably forbidden by the very laws of quantum mechanics. For any field to be perfectly still, its energy and momentum would have to be known with impossible precision, a direct violation of the uncertainty principle. The universe simply won't allow it. It's like trying to perfectly freeze a turbulent ocean. On the surface, it might look calm, but beneath, currents churn, waves surge, and countless drops of water are in constant, furious motion. The nothing of space isn't a blank canvas. It's a roiling, seething ocean of potential, constantly in flux, constantly moving. This isn't just theory. It's the first unsettling clue that the vacuum, the very emptiness around us, is alive. And it's teeming with a secret energy beyond our wildest dreams. The universe, in its relentless defiance of true stillness, performs an unimaginable trick. Because if nothing can be perfectly still, what does that mean for the empty void? It means it's alive. It means it's vibrating. Every single quantum field that permeates reality, the field for electrons, for photons, for quarks, is not sitting idly by. It's fluctuating, jittering, quivering, even in its lowest possible energy state. And these ceaseless microscopic tremors aren't just abstract wiggles. They are the genesis of something truly astounding. Out of this seething quantum froth, fleeting pairs of particles and their antimatter twins are constantly, spontaneously bursting into existence. For a brief, terrifying instant, an electron might materialize right next to a positron. A photon could wink into being, only to vanish moments later. They are born from nothing, exist for less than a blink of an eye, and then, just as rapidly, they annihilate each other, returning their borrowed energy back to the vacuum from whence they came. We call them virtual particles. Think of it like this: the vacuum of space is a cosmic loan shark, constantly lending out tiny, ephemeral bursts of energy. It allows particles to briefly appear, to take on mass and momentum, but only on the strict condition that they repay their debt instantly, annihilating themselves back into the void before anyone can truly measure them. It's a furious, subatomic dance of creation and destruction, happening everywhere, all the time, in every single cubic centimeter of what you perceive as empty space. It's like the surface of a pot of water just before it boils, seemingly calm, but below an invisible fury of bubbles is forming, collapsing and reforming, a maelstrom of potential energy. This isn't just a theoretical curiosity. It's the very definition of the vacuum's zero-point energy. Zero-point energy, the name itself is a cosmic paradox. It implies zero, absolute nothingness, but it refers to the lowest possible energy state a quantum mechanical system can have. And in this case, that lowest state is anything but zero. It's a riot. It's the intrinsic, irreducible energy inherent to empty space itself, a background hum of furious activity that can never be truly silenced. This isn't just some vague theoretical concept. It's a fundamental, measurable property of the universe. It means that what we call nothing is actually a dense, energetic soup, an invisible ocean teeming with potential, constantly bubbling with transient matter and antimatter, a cosmic engine running on pure, unadulterated quantum chaos. It's mind-bending, isn't it? This realization that nothing is everything is just one of the universe's many mind-bending secrets. If you're ready to dive deeper into these cosmic mysteries and keep pushing the boundaries of what you thought possible, then hit that like button and subscribe. You won't want to miss what else we uncover. Now you might be thinking, virtual particles? Zero-point energy? Sounds like abstract physics, a theoretical construct dreamed up by brilliant minds. And you'd be right in part, but the universe, in its infinite elegance, doesn't leave us stranded in the realm of pure theory. It provides a smoking gun, a direct, undeniable, physical manifestation of this seething quantum void. Prepare yourself for the Casimir effect. Imagine two perfectly flat, uncharged metal plates. Now bring them incredibly close together. We're talking nanometers, distances so small they make a human hair look like a cosmic cable. According to classical physics, if you put these two plates in a perfect vacuum, absolutely nothing should happen. They're uncharged. There's no air between them, no external forces. They should just float there, indifferent to each other, but that's not what happens. In 1948, Dutch physicist Hendrik Casimir predicted something astonishing. These plates, in a vacuum, would actually attract each other. They would be pushed together by a subtle, yet undeniable force. Why? Because of those furious, invisible quantum fluctuations we just talked about. The virtual particles, the zero-point energy. Here's the cosmic chess game. Outside the plates, the vacuum is boiling with all possible wavelengths of virtual particles. Imagine them as tiny, ephemeral waves, constantly appearing and disappearing. But between the two plates, something remarkable happens. Only certain wavelengths of these virtual particles, those that fit perfectly within the tiny gap, are allowed to exist. It's like a cosmic filter or a tiny musical instrument that only resonates at specific frequencies. The longer wavelengths, those that don't fit, are effectively excluded from the space between the plates. This means that the density of virtual particles, and thus the zero-point energy, is slightly higher outside the plates than it is inside the incredibly narrow gap. Think of it as a subtle pressure difference. The external vacuum, brimming with a wider spectrum of these fleeting energies, exerts a greater push on the outer surfaces of the plates than the more constrained vacuum between them. And what's the result? A tiny but measurable net force that pushes the plates together. This isn't just a hypothesis, it's an experimentally verified phenomenon. Scientists have meticulously measured the Casimir effect, confirming Casimir's predictions with astonishing precision. It's a force generated not by matter, not by charges, not by gravity in the traditional sense, but by the very emptiness of space itself. It is the undeniable proof that the vacuum is not inert, it's not passive, it's an active, energetic medium, a dynamic quantum foam that exerts tangible forces and influences the world around us. The Casimir effect is our window into the hidden reality of the vacuum. It tells us unequivocally that nothing is not nothing. It is a vibrant, seething, pulsating sea of potential energy, constantly generating and annihilating particles, a cosmic engine running at a furious pace. Even when we perceive it as utterly still, it's the universe whispering its deepest secret, that the void is, in fact, the most fundamental, active, and mysterious source of energy in all of existence. The implications of a vacuum that isn't empty are staggering. If nothing boils with energy, if it constantly spawns and devours particles, then the very foundation of our universe is built upon a cosmic froth, not a static void. This isn't just a quirky quantum phenomenon. It's potentially the universe's most fundamental, active, and baffling energy source. It's the hidden engine driving reality. Consider this. Where does the energy for these virtual particles come from? It doesn't come from anywhere. It is the vacuum itself. The zero-point energy is intrinsic to space-time. It's not a battery that runs down. It's the very fabric of existence pulsating with irreducible energy. This means that every cubic centimeter of what we perceive as empty space is, in a very real sense, teeming with more energy than all the stars in the observable universe combined. If only we could harness it. Of course, the challenge is that it's all in a state of perfect balance, creation matched by annihilation, making it incredibly difficult to extract in any useful way. Yet, its presence is profound. This cosmic background hum, this inherent energy of the vacuum, might even be a key player in the grandest cosmic drama of all, the expansion of the universe. For decades, cosmologists grappled with a bizarre observation. The universe isn't just expanding, it's expanding at an accelerating rate. Something is pushing galaxies apart, something we call dark energy. We don't know what it is, but its properties are eerily similar to what you'd expect from the zero-point energy of the vacuum. Imagine this: if empty space itself possesses a tiny inherent energy density, then as space expands, more empty space is created, and with it, more of this inherent energy. Unlike matter or radiation, which become diluted as the universe expands, the energy of the vacuum remains constant per unit volume. This constant energy density acts like a repulsive force, pushing space-time apart, accelerating the expansion. It's like the universe is inflating itself not with air, but with the boundless intrinsic energy of its own nothingness. This zero-point energy, this a boiling nothing, could be the very thing that's been stretching the cosmos for billions of years, pushing galaxies further and further into the cosmic night. This isn't just a theoretical possibility. It's one of the leading candidates for the identity of dark energy. The universe, it seems, is not expanding into a void. It's expanding because the void itself is an engine. The great silence of space, the apparent stillness, is a cosmic illusion. Beneath the surface, the vacuum is a roaring, vibrant entity, a quantum maelstrom that not only gives rise to fleeting particles, but may also be the ultimate architect of cosmic expansion. It forces us to redefine what empty even means. Empty space isn't inert. It's a dynamic, active participant in the universe's evolution. It's a source of limitless energy, a canvas upon which reality is constantly being drawn and erased, a fundamental force that shapes the very destiny of galaxies. The universe, it turns out, is far stranger, far more alive, and far more energetic in its nothingness than any of us could have possibly imagined. So, there you have it, the profound, mind-bending truth. Nothing is not empty. It's a furious, seething ocean of energy, constantly boiling with the birth and death of virtual particles, exerting real forces, and potentially driving the very expansion of the cosmos. The vacuum, this supposed void, is the universe's ultimate secret engine, a fundamental, irreducible source of power that underpins all of existence. Every atom, every star, every galaxy, even you, are dancing on the surface of this quantum foam. It means the universe is infinitely more alive, more dynamic, and more mysterious than we ever dared to imagine. The space between the stars isn't a passive emptiness. It's a vibrant, churning sea of potential, the cosmic bedrock upon which reality is built. The next time you look up at the seemingly empty night sky, remember you're not looking at nothing. You're staring into the face of everything. You're witnessing the profound, terrifying, and utterly magnificent reality of the quantum vacuum, the universe's most elusive and powerful secret. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion